Hi, welcome back to Moose and Chemistry. This is Colligative Properties, Lesson B. It's about freezing point depression, boiling point elevations. Well, colligative properties, remember, in our first lesson, colligative properties deal and count on the concentration of the particles, not on the identity of the particles themselves. Okay, so let's look at our first question here. A solution consists of 10.3 grams of glucose and 250 grams of water. What is the freezing point depression? So what we need to do is we need to find a couple things. First of all, we need to know our molality, which is moles of solute over mass of solvent, and that's in kilograms. Okay, so now let's look at how we're going to solve this problem. Oh, look at this. We have 10.3 grams of glucose and 250 grams of water. Both of those have to be converted. So let's go ahead and do our glucose conversion first. So we're going to need the molar mass of glucose, which is C6H12O6. So C6, so C times 12.01. H is 12 times 1.01. O is 6 times 16.00. When we do all the math, we get 180.18 grams per mole of C6H12O6. Okay, so we got that number. So now we need to calculate our grams of water into kilograms. So we go 250 grams of H2O, and we want to turn it into kilograms of H2O. So we put a 250 down here. We go 1, 2, 3, move it 3 spaces over, gives me 0.250 kilograms of water. So now we can figure out the molality, because that's the next most important step. So we're going to move down to this spot here because we have a limited space here. So we're going to go, let's see here, our moles. Oh, well, we could put our 200.250 down there. But we don't have the X, we don't have this space right here. This has not been calculated yet. But we did figure out our molar mass. So we need to come over here, and we're going to go 10.3 grams of C6H12O6 times 1 mole of it, of C6H12O6, divided by 180 grams, and 0.18, of course. And where did that come from again? Well, that came from right here. Okay, so when we get this comes together and gives us a total of, let's see here, do the math, got it, 0.057 moles of C6H12O6. All right, so now I've got all my numbers. I need this number here, and I need to put it right here. So I go 0.057. This is going to give me, divide the two together, gives me 0.228 molal. So now I've got my number here, and I'm about ready to solve this. So I'm going to have to clean up a lot of space here, so I'll be right back as I erase this. Okay, so I'm back here, and we're going to keep our number here. We have a little molal number, 0.228. So now what we need to do is we need to use our formula, which is delta TF equals IKFM. That's our molality. This is our freezing point constant. Okay. And this is called the Van Hoff factor. Van Hoff factor. All right. Now, you know what? The Van Hoff factor is used when we have an ionic compound. This is not an ionic compound. This is a covalent compound. This will not dissociate into ions. So our Van Hoff factor can just be 1. So anything times 1 is 1, as you know. Okay. So now what we need to do is we're going to go ahead and put our numbers in. So let's see here. Delta TF equals negative 1.86 degrees C over M times 0.228 m. Oh, where did this number come from? Well, that negative 1.86, that's the freezing point depression value for water. Each solution, like ethanol or any other kind of alcohols, whatever, has different freezing point depression numbers. But this one, negative 1.86, is for water, so we can use that one. So let's go ahead and cancel out our molals. And when we do our math, we're going to get negative 1.86 times 0.228, and that's going to give me negative 0.42 degrees Celsius. All right, so that solves that problem. So let's look at the next problem here. So what I'm going to do is I'm going to clear all the drawings and set up our next problem. Okay, let's look at another one. This one's going to be a boiling point elevation problem. So what is the boiling point elevation when 11.4 grams of ammonia, NH3, is dissolved in 200 grams of water? Okay, well, first of all, our molar problem, and our molality is moles of solute over mass of solvent, and that's in kilograms. Oh, look, we have grams. We don't have moles. That means we're going to have to do a moles to gram or grams to mole problem. So we're going to go from my grams, of course, to my moles. So that's like a stoichiometry relationship. So we need to get the molar mass of ammonia. So ammonia is NH3, so N is 1 times 14.01. H is 3 times 1.01. This gives me 17.04 grams per mole of NH3. Okay, so now we're going to convert that. So we go 11.4 grams of NH3 times 1 mole of NH3 over 17.04 grams of NH3. So when you do the math, you come up with approximately 0.67 moles of NH3. Okay. Oh, look, this is in grams, not kilograms. Okay, so I got to convert that. So I take 200 grams of H2O, and I want to move it into kilograms of H2O. So I put my 200 down here. You have to move it over 3 spaces, going from grams to kilograms. So it gives me 0.200. All right, now I can figure out my molality. Remember that molality is moles of solute over mass of solvent in kilograms. Okay, well, let's get this going here, okay? So we're going to go molality equals 0.67 over 0.200. And when we do the math there, that gives me 3.34 for my molality. Okay, that's great. Let's make that a little bit nicer. Okay, now, all we have to do now is do the delta TB. So delta TB is equal to IKBM. Again, there's our Van Hoff factor. You know what? Ammonia, NH3, is a covalent compound, so the Van Hoff factor is going to be 1. So we really don't need it. Now the KB for boiling point water, that value is going to be, the constant is going to be 0.51 degrees C over M. And again, this would be a different value for a different solution other than water. So let's go ahead and fill this out. So delta TB equals, and we can just forget the Van Hoff factor, 0.51 degrees C over M times 3.34 M. So cancel out our M's there. And our delta TB is going to be 1.70 degrees C. So our boiling point is actually going to be raised by 1.07 degrees Celsius. You guys have a snarling day, and we'll see you back at Moose in Chemistry.